Uh, hey, folks! Thank you all for joining this webinar series. So I have Shayak and Yuvnesh from Truera and TruLens, and I have Shishir who's joining us from Berkeley. One of the schools I always wanted to go. Have read so much about, and then obviously Shayak is from CMU, another school I wanted to go. So they are the smart ones. So it's great to have them here. Great to have them on the series. So we call this the Decoding AI series, webinar series. And the attempt is to enable access to smart experts, knowledgeable experts in AI for the Indian audience. I'm sure we have a few people logging in from Europe as well, but that's the intent. And Shayak and Shishir and Yuvnesh are on the cutting edge there. So thank you for doing this for us. This series is part of our Axel Atoms effort, accelerator. Axel Atoms is Axel Atoms is our accelerator effort, which we announced a couple of weeks back, where we are inviting startups working in the space of AI to come and apply to us, and we give them investments up to $500,000. But more interestingly, importantly, is we're trying to build a network of AI experts who can guide them. I think that's the more powerful thing to be part of this, right? So if you are interested, please go to atoms.axel.com. And with that, I would love to, just let Shayak and Yuvnesh take it over for the first part of our webinar today about evaluating LLM apps. And then after they finish, we will get Shishir on to talk about Gorilla. And in the meanwhile, folks, please feel free to point all your questions to in the Q&A panel, and we will try to pick them up periodically every few minutes. So that's where we are. And I have also enabled chat with everybody, so people can also write on the chat if people want to introduce themselves. So with that, Shayak, Yuvnesh, all to you. Thank you. I'll go on video. Thanks. Yeah.
Thanks,
Thank
Priyank.
you so much. And I think we would love for you guys to keep it interactive, keep the questions flowing, and we can also just tag team and answering the questions offline and online as they come along. So I'll just share my screen and let Yuvnesh kick things off.
Awesome. Yeah, so a quick introduction about Truera. Truera is a company in AI observability space, and our mission is to make machine learning applications more measurable, explainable, and responsible. So, with that in mind, we actually launched our open source software called TruLens, which is helping LLM app developers evaluate and track their experiments. So, one of the first things we talk about, so Shaq, if you move to the next slide, yeah, is that LLMs inherently are hallucinatory. This is feature, not a bug. So it's interesting thing to say because like when LLMs came out, ChatGPT came out, LinkedIn's were full of posts about like, you know, this is end of Google search as we know it. And this is what's going to be the table stakes things going forward. So out of curiosity, I actually did the search. This is on Claude 2, which is Anthropic LLM. So I did the search like who are the founders of Truera, and it gave an answer which looks pretty legit, but only problem is that it's completely untrue. I would take it back. Not completely untrue because like it's showing three co-founders. Only one of them is a true co-founder, which is Anupam. But the other two, Shomesh and Tomo, has nothing to do with the company. So but the way it's written, it's like looks pretty legit. And like,
Yuvnesh, I was actually quite offended by this because one, I got dropped, and two, I also found out from this that our company was acquired 5 years ago, which I just
yeah, like I actually came to you and said like, hey, like I didn't know we got acquired. I thought I joined as a cool Series B startup. So yeah, like this was like And the challenge is like there are some bits of truth in here because, as I mentioned, Anupam is a co-founder. This the company is headquartered in Redwood City, and it does help in AI auditing and risk intelligence, and has risk intelligence capability. So it looks pretty legit, and it does a good job of making someone think that this is who Truera's founders are, and this is the state of the company. So I also did another search, which is more generic, that who are the founders of Google. And if you see here, the answer is pretty, I would say, almost 100% accurate out here. So, how's both things possible? That, like, for one case, like for Truera's co-founders, it's giving a very random answer, which has some bits of truth in it. But for Google, it's got like really a great answer. So, Shayak, you are the PhD. You tell me, like, how this
It's a
what's
great
happening.
question. So, and just taking a step back, right? Like the way a lot of these models, it's like a result of decades of research, but essentially decades of machine learning research has optimized models for generalization and actively parallelize memorization. So memorization is when you're overfitting, you're doing bad things which you're not expected to do. But when you have LLMs, they're trained on so much data, you end up memorizing at least some facts. And so there is an intersection, but this overlap between generalization and memorization is actually quite murky. It's hard to really understand what's in the middle, what's on the left, and what's on the right. And and essentially, uh, what what Claude 2 did on the left hand side was created a very nice general answer, and it's actually what it's designed to do in the absence of perfect facts. Whereas the Google answer, in some ways, has become a part of the structure of English language itself, and so it kind of exists in this intersection, but it's hard to tell what's in the intersection and what's not. So, so just the takeaway from this is that LLMs, in some ways, are trained to generalize. They sometimes have happen to memorize as a side effect, and then what that really means that they sometimes happen to not have hallucinate as a side effect. So we can't really uh, rely on it to get factual uh, answers, right? And this is a real problem that 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 we need to solve. And 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 before we kind of go a lot deeper, we'd love to do like just a quick straw poll in the chat on like just to get a sense of what kinds of applications this crowd is building. Are you building agents for healthcare, racks for recruiting, and so on? Would love to kind of see from this audience what people are working on. I'll I'll fall into the chat to see what's going on. Right. So Rajiv is building an agent for uh, building web apps. Really cool. Awesome. And Rupesh is building LLM8. And marketplace for apps. Priyank, you're building a summarization and classification app. Yeah, you told me about this when we met in SF. That's pretty cool.
So, Priyank, are you trying to take away your analyst job by doing this?
But is this so? It is so hard to keep track of what's all happening in the AI space. So many papers. They're like, this is the best way. Just use RSS feeds and
Yeah. Makes sense.
Cool, right? Yeah. So sounds like there's agents, summarization, rags, and we'll touch upon a bunch of these in this webinar and talk about how to think about hallucination and quality in general. It looks like Rachit is building apps for legal QA where obviously you can't hallucinate. So
Yeah.
these are all great apps for thinking through careful evaluations. Right. So we kind of came to this stark realization that hallucinations are kind of a feature, not a bug. So what's the way forward? Essentially, one way to think about it is to really focus on the left-hand side and let LLMs focus on these general tasks like summarization, text embedding, inference, agent reasoning, so on. And then while doing that, leave the memorization to some other system. And then what what this motivates is that obviously you have these kind of large set of memory stores now, which act as vector DBs, which you can query and act as some concrete memory over your knowledge base. And these are some examples in no particular order of things that people use. And using this, a lot of people have essentially put their faith in RAGs. And RAGs is just a very general architecture for combining memory with an LLM. This is like the simplest form of a RAG where you're asking a you're transforming your question into an embedding, retrieving the most important chunks of data using that, and then using an LLM to summarize and complete the answer. So this is a good start because you now have some grounding in a database that you can query for facts and things that can be checked. But what we have found is RAGs can hallucinate as well. And Yuvnesh, you can
Yeah.
in this right here.
Yeah. So we actually using RAGs built an internal chatbot. So what we did was we took our company website and kind of chunk that and put in a vector database, and we build a RAG application on top of it. So one of the first things we asked, like, "Hey, who is Shayak?" And it gave a pretty good response, which a lot of them is true. But right at the end, the ones which is highlighted that it's mentioned that he's also a member of Bank of England, England's AI Public-Private Forum, and the OECD Global Partnership on AI, which made me think Shaika actually has only been in academia before and has been at Truera. Like, how does he get this time to become member of Bank of England?
Yeah, I
So,
mean,
but
I would have
also
loved
I
to
felt
be.
like there is someone who might be in the company who might be doing this. So, does that mean Shaik automatically becomes that? So we are seeing that even rags are hallucinating a bit. So what's going on here?
Yeah, like at first glance, it's really hard to debug what might be going on here, and which is why we kind of created this framework for hallucination for RAGs, which we call the RAG triad, where essentially you have these three edges of or like three sides of a triangle would check for consistency between these three things, which are the query, the context, and the response. So the query is the question you asked, the context is the context which was retrieved, and response is the answer which you got. So what you can start to do is to check for consistency between these three things. So the first edge is, hey, is the context relevant to the query. The second one is groundedness, which is the response you created. Is that response essentially based on the context, or is it coming from somewhere else? And then the third is question answering relevance, which is the response. Is this even relevant to the question? And these three things are independently checkable, and we'll walk through this a bit. But each three of these together gives you reasonable confidence on whether you're potentially hallucinating or not. So I'll go a lot deep deeper into this in just a bit. But essentially, getting all of this evaluation right requires a lot of experimentation, where you build an initial version, you test and eyeball results, and you iterate with prompts, parameters, and fine tuning. And there's a big gap in the dev tooling to essentially evaluate and track your experiments, because you essentially want to do these together, right? You want to make sure you are quantifying how good your app is while you're doing this kind of an experimentation loop. And this is very familiar to data scientists who have lived through AI 1.0. This is exactly how you build models, but in AI 2.0, in this world that we live in, this is actually quite hard to do. Which is why we built TruLens, which is essentially an open source tool to help you track and evaluate LLM experiments. And essentially, as you build your LLM application, you connect it to TruLens, and everything you do here essentially then gets logged automatically in the background and evaluated. So the thing you do to evaluate them are these things called feedback functions. So feedback functions are essentially things that, and we'll go a lot deeper into it, but feedback functions essentially let you answer the kinds of questions that we were looking at, things like context relevance, things like uh, things like groundedness, and so on. And once you have this, you essentially then get this leaderboard, which gives you a sense of how much progress you've made as you've iterated on your chains. So, so just to kind of take a step back, essentially, if you have apps built with things like LangChain, Llama Index, or even other custom frameworks, and you're building RAGs or doing query planning or data agents summarization, you can essentially use our feedback functions to test the things on the right hand side, which are things like relevance, groundedness, but also things like sentiment, language mismatch, like the length of your transcripts and so on. And also balance that with things like cost and latency and so on. So we'll walk through a lot of this stuff as we go through the rest of the talk. Cool. So and would love to have you guys try it out for yourself. Give us a star, request a feature, and contribute. This squid emoji is a real emoji and should be scannable, but uh, uh, see if it works for you or not. All right. So just returning back to just the code. Essentially, if you've built an app with something like LangChain or Llama Index, you can essentially connect it with a very few lines of code to uh, TruLens by wrapping it, and then everything that goes through the app goes through the evaluation process. So a deep dive into what a feedback function is. Like we discussed 3 kinds of questions you might want to answer with a feedback function, which was the RAG triad. But then you can do a lot more as well, like things like prompt, sentiment, language mismatch, and so on. So if we then go back and take this RAG triad back into what happened in the question, and when we ran this through TruLens and asked it, hey, who is Shayak? Essentially, what we found was that the context retrieval was broken. And essentially, what happened here was 2 of the chunks here were about me, and 2 of the chunks were about a different person who also works at Tuera, Shamik, and 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 even though the the answer was grounded in the context, what happened here was that the the context retrieval confused the summarization, which led to essentially this hallucination, which was still based off of the context, but uh, provided a wrong answer. Right. So this is a very interesting kind of example where the where you can then pinpoint the fact that you had a hallucination down to the fact that the context which was retrieved was incorrect, and then you can do a number of things here to try to improve this. You can either filter this context based off of the feedback functions, or you can choose to improve your retrieval in some way. My guess here is that because of the tokenization for the embedding, Shayak and Shamik are close to each other. My guess is this is why uh, this retrieval didn't work well. But those are all things that can be experimented with. So at this point, I'm seeing a bunch of questions showing up on chat. Uh, and let's take a few of these questions. I think Rachit has a question about best practice evals and for RAGs, and a big consideration here is this RAG triad, and we'll go through some more example of this. But this triad essentially lets you do a comprehensive check for consistency, and lets you have reasonable confidence that uh, the answer that you're providing is both based on the context and is relevant to the answer. Great. So just moving on really quickly, it can be the case that hallucinations can also be factually correct. And now this is kind of going back to that intersection. Uh, this might seem like a bit of a paradoxical statement, but essentially, this app was built on Wikipedia, and we asked it name some famous dental floss brands, and the answer it came back with was dental floss brands include Oral-B, Colgate, Glide, Reach, and Dentec, and these are all legit brands. So the reason this failed our triad is because even though this answer is correct, none of it was actually based off of the context which was retrieved. And in fact, the context did not have these names at all. And this is something you might want to check. And then uh, the last one is the third edge of this triad, which is you might be answering the wrong question entirely. So, again, for the same app, we asked when was Hawaii State song written, and in this one, the the app responded with the name of the song instead of the year, uh, which is which is not what you want. So in this case, you're not checking for factual correctness. You're checking for the fact if that the response is potentially a legitimate answer to the question. So so that's an example of how you can have failures at all three edges of this triad. Great. So just to recap, in order to get to a reasonable confidence that a rag is not hallucination, is not hallucinating, there's a few things you need to check, and I'll let Yuvnesh cover the recap.
Yeah, so I think as we mentioned in the triad, from app development perspective, I think the three critical checkpoints typically happens like when you're trying to generate the right context chunks to query your vector database. So are you generating the right context chunks? I think you really want to like look into that. Second is like when the response is being generated, like you want to really see like is that really grounded in real data. So to flip my initial statement a bit, like if you are getting if the response is not grounded in real data and you're still getting a right answer, that's actually a bug mostly because it's really hallucination happening, but you're just getting lucky and it's not a very sustainable model if you want to run an app in production. And lastly, like is the response generated is relevant. Like you can have like let's say a customer support chatbot and customer might ask a question, is generating a correct answer, but it's not answering the customer's question. So from a business perspective, you're failing. So I think these are like three very critical things. Like when you actually are shipping a RAG-based app to production, you might want to stress test these three things out before you confidently ship it there. So yeah, those are like some of the the three key pillars of how TruLens operates for LLM apps.
Perfect. And then just moving on, we'll get a bit more hand hands on and look at kind of a typical workflow of how you might want to build an effective QA app with while experimenting with something like LangChain, your vector DB, and TrueLens with it. And essentially, in order to get to the best or optimized app, you want to experiment with a number of these things, with just how is your vector DB constructed, what data is in it, what's not in it, what is the chunk size you're using. You can also choose your chunks to be overlapping. Uh, you also want to experiment with different distance metrics, the embeddings you actually use, and 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 parameters of your retrieval, such as the amount of context you retrieve, if you're doing any kind of query planning or not. And then on the LLM side, uh, you want to change your prompting, the choice of your model, the parameters that go into your models. And when you do an experiment like this, essentially, you then end up with a leaderboard of options with where you can then evaluate the trade-off between the latency, the cost, and the quality metrics that you're tracking. So there's a notebook example here which you can follow along on, and this is something I'll just walk through in some amount of detail to just give you a feel of what a typical experimentation workflow can look like. And essentially in this one, we are
Sorry,
building.
sorry, Shayak. The can you zoom in a little bit?
Of course,
It's
yeah, yeah. Great point. Is this a good
I
size
think that,
to?
yeah, this is
yeah, this
perfect.
is good. Yeah, this is perfect. Yeah.
Perfect, thank you. Yeah. So in this example, we'll walk through different versions of the same app with different parameters, and all of it will get logged into TruLens and eventually get evaluated. And and uh, and all of the index construction and so on takes a while. So I won't run this live for you, but you should feel free to uh, go to our repo and run this yourself when you have time. So in this one, we are first creating an index on Wikipedia data. We loaded the data itself from Pinecone, and in this case, we are first creating an index which will use cosine similarity, and with a dimension length of 1536, which happens to be the dimension of the OpenAI Ada 2 model, which is what we are going to use here to index the data. So uh, so essentially we just go ahead and and index this. Once we have that, uh, we can use LangChain to build a simple RAG app around this, and then evaluating with TruLens is actually very straightforward. So all you do is wrap it with this thing called TrueChain, which is our LangChain wrapper, and and these two other parameters are optional, where you can give it a name, and you can then say, hey, these are the feedback functions that I want to use. So I've defined the feedback functions here. One of this is question answer relevance, and the other one is the question statement relevance. So these are two of the edges of the RAG triad that we were looking at. And then I also have like a set of test questions that I want to ask here. So essentially, once you run this, all of this gets logged, and 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 you can see a lot of these results in just a simple leaderboard. So I'll this is actually a leaderboard from a different app, which we'll cover in a bit. But I just wanted to give a quick sense of the kinds of things that you can do with it. You can go in, look at specific records. You can see how the feedback functions ran. You can look at how long each call took and the results of the the feedback functions and so on. So just returning to the notebook itself, the next thing to try is to try a slightly different distance metric. In this case, I'll use an Euclidean distance metric and run the same experiment, see if the results are diff or different. I can also use a dot product. Uh, and then as I try more things, I can also try changing my LLM itself. So instead of using GPT 3.5, in this case, I'm using Ada 1, and then uh, I can switch back to uh, GPT 3.5, but change my retriever parameter to just retrieve one document. So just returning to what this looks like in a dashboard. Essentially, I've tried out a number of different parameters, and then uh, decided that the one that works best is the last one, which is the right trade-off between cost and the metrics which I was tracking compared to everything else. So this is just an example of, as you're doing this experimentation, you ideally want to make sure you're doing that in a systematic way, logging everything and running it on the same test set to make sure you're actually improving, as opposed to doing some local optimizations. And I'll let Yuvnesh cover a few of the things that we have seen in terms of evaluation pitfalls and best practices uh, when we work with our users.
Yeah, so ever since we launched TruLens, we had a lot of individual developers and smaller size customers who are working with us to vet their application using TruLens. So some of the things we have seen, so one of those are that sometimes the prompt engineering can hyper focus on a single example, and when you can't as a app developer, you cannot control the users all the time, and you might get instances where users might have some inputs which kind of fall outside some of the guardrails, or like some of the examples you thought of in the first place. So focusing on like very narrow use cases and like prompt engineering for that leads to like a very bad end user experiences. Next one is strike if yeah, is around like if you're not testing the performance periodically. So one thing, most of you folks have been working in LM space, and the changes are happening almost on a daily or a weekly basis. So the base models keep evolving, and because if let's say if you're using something like GPT 3.5 or 4, they are constantly optimizing. OpenAI is constantly optimizing them for their cost purpose. So the way a certain GPT model was behaving like a month ago, it might not be behaving anymore. So you have to keep on periodically testing these applications or your implementation of on these models. And also one of the things we keep telling our users is like you should start building a golden test set where you can basically keep stress testing the golden test set for all the three value pillars which we spoke about, and specifically like to test for if any changes in these base models is actually affecting any of those metrics. And lastly, oops, so uh if you don't set up like a comprehensive evaluations, as we said, like people might just focus on the input and outputs and not what's happening in between. That can often lead to some of the failure modes, which is not very well understood in terms of like what happened in between, which is leading to bad outcomes. And you might not do a good job of solving the root cause, and you just might solve the symptoms. So trying to like figure out, like slice and dice entire value chain and seeing like wherever the hands of are happening between LLMs and let's say your application or the vector database is really critical to understand like are all the metrics looking pretty clean before you ship the app. So yeah, these are like some of the pitfalls we are seeing, and I'm pretty sure like we'll encounter more as this space evolves. So next thing is we wanted to chat more about the agents application, which is picking up a lot of steam. So one example we had, if you move to the next slide, is how do you leverage external knowledge, third-party knowledge in real time? So a good example of this is I was curious, what does ChatGPT think about where you find the best biryani in San Francisco Bay Area? So if you look at this response, you can see like there are a lot of problems with this response. So one is that the last knowledge update was September 2021, and lot has changed in restaurant landscapes since then. So maybe like a quality of some of these restaurants that's listed here has gone down. Maybe some that's shut down, or there's a new entrant, which might be better than all of them. Also, other nuances are that it's telling me, what are the top 5 restaurants. So there's no active way to understand that if the first option, which is Zareen's, versus the second option, like what's the delta in difference in them? Like Zareen's might be rated 4.8 on Yelp, and the Biryani House might be rated 3.8, which is a huge difference. So there's no way to understand that context. And also like there are other things that a third party source like a Yelp can provide, which is, you know, what's the demographic of people who are giving these reviews? Is it is this response optimized for, general, not for a certain segment? Like maybe people who are from India might like certain biryani better than people who are from US. So those are the nuances we cannot get from this response, and we need a third party data source to uh, augment this. So the next slide is basically where we introduce the concept of data agents. So data agents are typically an API or some external source where we actually make a request to get information about whatever the user input is and augment the agent's reasoning based on that. But relying on a new data source which is external to yours can add actually newer complexities into this system. So if you go to the next slide, you'll see that like you can possibly have like two things that can happen is that you might actually have a wrong tool selected for whatever application you want to ask for. So let's say if you are asking for best biryani and somehow you're asking Reddit, you might not get the best possible answer, and which is grounded in like social intelligence, so to speak. And also like the way you're asking the question to this third party data source can create other problems because like it may not understand the inputs you are generating in the system, and it might throw some kind of a weird error. So what happens if you encounter those paths? So if you go to the next slide, Shaq. So one of the things a lot of agent developers we are working with is they encounter something called a rogue path, and this creates like an infinite loop for an end user where they keep getting back to the same query or same response, which is not helpful at all, and leads to a very, very broken user experience. So this is also a form of hallucination, and it's basically, uh, if you go to the next slide, it leads to the dinosaur experience. This is the experience when your Chrome stops working, you get a dinosaur. It's basically you're getting the same experience where your app becomes useless. And we think like this is another form of hallucination, which we possibly can solve with TruLens. So Shag, the question is like, how
And uh,
does
and and by hallucination, you mean a bug in a general sense, and not that it's being factually incorrect, but
Yeah,
it's yeah, you just have a uh, like just a bad outcome uh, from the use of the app.
right. So
Yep.
now the question is like, how can so what's the difference in a RAG based application and an agent mode, like or an agent based application, where TruLens can help users, you know, uh, not have these build these experiences in their implementation.
Yeah. So the other thing which can happen, which is the same thing as in a RAG, which is that as you're in this reasoning loop, right? You can also hallucinate different pieces of information, and that's useful to check for as well. So in this example, we essentially built and again, you can find this notebook on our repository where and we have a few different agent examples, but in this one the agent just has access to the Yelp API, and it does things like uh, query translation and so on, and these are all things that you can check for. So so we'll just switch over to another notebook really quickly. So, was I? Yep. So in this notebook, we're essentially using Llama Index as a
Like you need to zoom in again.
all right.
Yeah.
Awesome. All right. Yeah, so we're using Llama Index as the query engine with this agent, and we're using Yelp from Llama Hub as a tool that goes into this. And again, uh, the the app itself is created in the same kind of way as before. And what we do here is also create a separate just standalone app. And this one is just using ChatGPT directly for just comparison as a baseline. So so in this example, we are setting up a number of different feedback functions. Some of these are custom feedback functions, which is, for example, in this feedback function, and we use using Chat GPT to see if the question translation was correct or not. And in a different one, I'm actually seeing if the results is 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 used or not. So there's things that might be very specific to your app or use case that you might want to check. And the other things that I'm checking are things like uh, groundedness, relevance, and so on, and setting that up with this test set. And when I run this, and Priyanka, I think you asked if you can just fire off a number of different tests at the same time or not. You can do this, and essentially, what we do behind the scenes is uh, run a separate process that does all the evaluation in the background, so that you you don't have to wait for it in your notebook in some sense, and then you just wrap the Llama Index agent with True Llama, which is our Llama Index wrapper, and again you get the same kind of view into what's going on. Uh, you understand where the whether the query translation was right or not, whether you were providing the right answer and so on, and you have a view of what's going on with the different parts of this app. and 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 how long each part might have taken. So just re- re- returning to the leaderboard, you see that the Yelp agent which we have created is still quite fast, because you're using a fairly fast API instead of AI, and then at the same time you can do a lot more evaluations because you have access to some amount of context that lets you evaluate how well your app is doing. So just returning to this discussion, we essentially find that uh, overall, by using a tool and going through this agent reasoning loop, you can just answer questions about more recent things, and do a much better job of uh, just answering more complex questions than, and while having kind of references that go back to real data. Cool. So just in terms of uh, what you might want to check on this, these were the things that we were discussing. You want to uh, you want to check uh, the question answering relevance, the groundedness, the context relevance, but especially when you're in this loop, you also want to check for how the question translation is happening and so on. So there's some additional things in the triad that you might want to check, and then in the in the results you can verify if the correct retrieval is happening. You can check if the right context was retrieved. You can check that the app response is supported by the context, and you can also check if the response helpful or not in terms of the question. So this is just extending the RAG triad which we covered, and making it very easy to test agents to see if they work well or not. Cool. So that was it in terms of the presentation that we have. I again would love for you to try it yourself, and give us a star, request a feature, and contribute. We're actively building more evaluations, more ways of slicing and dicing your data, and would love to hear from you.
Also, one call out. We didn't add this here, but we also have a AIQ community or AI quality Slack community where you can join and interact with other developers and also some founders, where people are building interesting applications and they are dropping in any feature request or any issues they might be having. And sometimes simply is like, they are struggling with something. Doesn't have to do always do with TruLens, but they just want to pick someone's brain, and someone will be there to answer your question for sure.
Hey, guys, can you add that Slack community channel probably here in the chat? I think folks might want to
Yeah,
join that.
sure.
Yeah,
I'll do that.
But I think that the billion-dollar question is what Rajiv has asked: uh, why do the LLMs hallucinate, right? Or it's maybe a trillion-dollar question. I don't know. So, um, but yeah, I think like any digs on that? Like, how do we have any idea? Like, why does it happen even at the same temperature setting? So
yeah. I think obviously why do they hallucinate is because they're designed to do so, right? Like that's what, when an LLM doesn't have something memorized and it's not in that intersection, you're it's kind of designed to create plausible looking text that makes sense. I think Rajiv's question was a bit more nuanced than that as well, which is uh, what even at temperature zero, why are they not deterministic? Uh, so I don't have full access to exactly how the LLMs are deployed and implemented, but is essentially my sense is as you are running these in a distributed way, you have slightly different execution patterns and so on, which can lead to slightly different uh, outputs as you execute your full network. That can introduce a bit of non-determinism in the system that gets amplified by how non-linear the networks themselves are, and small differences in execution order and floating point precision and so on can also just lead to very different uh, outcomes in the apps. That's just uh, my explanation or rationalization for why temperature zero also leads to different answers at the same time. But if somebody else has a better view on it, would love to hear. And yeah, just to kind of point people towards the community. Essentially, if you go to TruLens.org, and we'll paste the link as well. That there's a big joint community link here, which takes you to our community that essentially gives you access to everyone who's working on TruLens, a lot of support and discussions, and also if you're thinking of contributing, there's a dev channel there where we discuss what to build next and so on. So would love for you to be a part of this, and we'll post the link on the Zoom chat right away. Uh,
Well, one question I have is, and I think this meme resurfaced back, was Chat GPT or GPT is not so good at multiplying numbers.
yeah,
Right. And that seems to be very fundamental.
yeah,
So one question: have you guys and you guys work on the eval side, right? So have you seen apps being put in production, um, who then just pass on all the arithmetic to somebody else for doing that?
absolutely. Yeah. So just returning to the agents and tool discussion. Uh, where were we? Yeah. So a
I
bunch
think yes,
of
I did.
the
Yeah. Mhm.
yeah a bunch of one thing you can do is set up tools to specifically do arithmetic and which is why there's support for things like Wolfram Alpha, which is more of used as a calculator or math engine to do to solve math questions. And you still need the LLM to kind of decide, hey, this is an opportunity for me to use this app. So you still need that kind of agent reasoning to one decide which tool to use, what parameters to call it with, and so on. But that's absolutely the kind of uh, use case for tools and agents for these kinds of apps.
Nice. I think there's one debate which we had just a couple of hours back was,
Yeah,
uh, we have LLMs, but then people for doing these specific tasks, like this arithmetic, and calling an API for that seems like an overkill, latency, and all of those things. Like, would people try to put in smaller models? Does it make sense? So you will have I don't know if I'm making sense, but specialized models only for that functionalities.
Yeah, that's a great point. I mean, there's some smaller models which are much better at arithmetic than others. You can also potentially use just offline calculators in some ways, right? Like you don't have to call a tool that's an API. Uh, I think there's like you can think of simpler models as tools as well, and I think that's a great lead in, hopefully, to the discussion with
Yeah,
Shishir as well, where his framework is optimized for making the right kinds of API calls. So yeah, I think
all
that's a
right.
great discussion to have in that context as well.
Yeah, I think he's just joining in a minute. I think he has some trouble with Zoom.
No
Um,
worries.
yeah, but one other question is like how so Langsmith is going differently and TruLens is going differently. Is it that's the way we should think about it in terms of like these are different tools essentially for
These
eval.
are different tools. Yeah. So Langsmith is really focused on kind of just uh, logging and tracking, especially for LangChain based applications, where we're taking just a more open approach where you can use LangChain, Llama Index. You can use your own framework and and instrument it, and also making it very easy to have these custom evaluations of different kinds. So it's a very different approach in some ways where we are focused on kind of creating an open ecosystem of evaluations across all platforms, across all kinds of apps, where Langsmith is kind of focused on tracking for LangChain in with some very specifically defined uh, uh, with very specifically defined evaluations, which you may or may not be able to customize. Yeah.
Yeah, awesome. Thank you. And Shishir, I was just texting you. I think Shayak has just talked about just the agents and API space, and it's not always easy to call them up. There's always hallucination. So we're very curiously discussing how Gorilla solves for this. So I think perfect timing. So awesome. Shishir, the floor is all yours. Shayak and Yuvnesh, thank you for doing this. And
Absolutely.
folks,
Yeah.
yeah.
Thanks
Uh,
for the question. Thanks for the engagement.